Welcome to Maths with EJD. I'm still talking about cooperative games, and in this video, I'll be talking about the Shapley value in cooperative game theory. So let's look at an introduction to Shapley value. So in the previous video, we had looked at the core of a cooperative game, and we discovered that the core of a cooperative game is that payoff that will ensure that none of the cooperators, none of the collaborators actually walk away from the deal. So introduction to Shapley value, let's look at that. The Shapley value is a solution concept used to fairly distribute the total payoff of a cooperative game. So the fair distribution of the payoff of the total payoff of a cooperative game, that's what this is about. Fairly distribute the total payoff of a cooperative game among players based on their marginal contributions to every possible coalition to every possible coalition. Of course, we already know the idea of coalition that the grand coalition is the coalition of all the available players, but then one or more less than the all the available players can then form sub coalitions. So in this case, we talk about every possible coalition, marginal contribution of each player to every possible coalition. So it takes into account all possible orders, all possible orders in which players would join a coalition. So the order of joining is really important here. It takes into account all possible orders in which players could join a coalition, ensuring a fair allocation of the payoff. So, the order in which players join a deal can actually determine how much value they get from the deal. So, the Shapley value for a player I is calculated as phi I of V equals the summation of all sigmas belonging to Sn 1 over n factorial, then multiplied by the value of S sigma I minus the value of S sigma I take away I. Okay, something like this, where where Sn is the set of all possible permutations, the set of all possible permutations of the players. Okay, then we have the value V of S sigma into I is the value, that is the value of the coalition, the value of the coalition S sigma I. And this actually includes player I, which includes player I. This includes player I. All right. So, of course, it's clear that I is the solo coalition of I, if that's anything to go by, if that's something we can say, the solo coalition of I. That means the set containing just the player I. That's all. Okay, so let's take an example to drive the point home. So we have an example. Given three players, A, B, and C, and the following value function for the game. Okay, first of all, we have the value of A alone. That's four, whatever that is, maybe $4 million, $4 billion, or 4 billion naira, whatever. Then value of player B alone is 5. And then the value of player C alone is 3. Then let's look at them in pairs now. So we have um, the value of players A, B. So we have a coalition between A and B in that order. So that is 9. Then we have the value. Okay, I think it's the kind of thing we had seen before. So then we have the value of A, C, players A, C, and that is 7. We have the value of the coalition between players B and C, and that is 8. Then we have the grand coalition. So the value of the grand coalition of all players A, B, C is actually 12. Okay. Now, having done that, the next thing we want to talk about is this, is that we want to calculate the Shapley value for each player. Okay, so that's our goal, to calculate the Shapley value for each player. So the first step 1, we need to list all possible orders, the orders in which the players can join. List all possible orders, which you can also call permutations. So there are 3 players. So in how many ways can we arrange these 3 players? So we say that for 3 players, the total number of permutations will actually be 3 factorial, which is 6. Okay, I mean 3 factorial is 3 times 2 times 1, which is 6. So we're going to have 6 possible combinations of this. So, and the 6 possible combinations are A, B, C. So A can start the coalition, B joins, and then C joins later. Then we can have A, C, B. Then we can have B, A, C. Then we can have B, C, A. And then we can have C, A, B, as well as C, B, A. So these are the possible orders in which the coalition can be formed. So we can imagine that the first person, the first player in the coalition is actually probably the person who starts the idea, and the second person is the next person, the first person who buys into that idea formed by the first person, and then the last person is the last person to join the coalition. So, and the order in which they join really matters, and that's why we have to do this. Okay. So having done those six computations, these six permutations rather, we go for step 2. In step 2, we now calculate marginal contributions. Calculate marginal contributions. Calculate marginal contributions for each player in each order. Okay, that is what step 2 is about. So let's look at order 1. So order 1 where we had A, B, C. All right. So here we say A contributes. So A, who is the first person to join the coalition, to start the coalition, actually contributes 4, which we had in the beginning. So A contributes 4, as we have here. Okay. And then as B joins, right? So B contributes V of the value of the coalition between A and B. So that's V of A, comma B, actually minus the value that only A brings into the A starts with, and that is actually V of A, comma B. V of A, comma B is actually 9. So we have 9 minus 4. So this is 9, and this is 4, So that's 9 minus 4, and that is equal to 5. So we have that. Now, then we go for C now. What is C contributing into this coalition? So C contributes the value of the grand coalition, A, B, C, minus V of A, comma B. Okay? Because A and B are already here. So whatever is being added to this is now the grand coalition. That is 12, as we already know it. This is 12. So that'll be 12 minus 9, because V of AB is 9, and that is equal to 3. So these three values are important, this, and this. So we need to take note of that. So that is for the order ABC. Now, after ABC now, then we move to okay, we are still in step 2 actually. So then we go for order 2. I mean, this is a lot, right? So for order 2 now, so if A starts the coalition and C is next and B is next, okay? So this is order 2. And for order 2, we follow the same thing. So we know that A contributes the value associated with A alone, and that is simply 4. Then next we say C. C is next. So what would C contribute now? C contributes the value of A has been there already. So the value of A, the value of A, comma C, minus the value that only A contributes. And the value of A, comma C again is the value of A, comma C is 7. So we have 7 minus 4, and that is 3. Then what does B contribute? So B contributes the difference between the value of the grand coalition, the difference between the value of the grand coalition A, B, C, and the value of the coalition between A and C that was already there before C joined. So A, comma C. So the value of the grand coalition is 12 minus the value of AC is 7, and that is also 5. So then we have 4, 3, 5, like that, 4, 3, 5. Then we go to the next order. So we have order 3 now. Okay. For the next order, order 3. So order 3 is B, A, C. So that means that B starts the idea. All right. B starts the idea, then A joins, and then C joins. So first of all, we see that contributes, B contributes the value attached to only B. So the value attached to only B, and that is equal to, the value attached to only B is 5. So this is 5. So next we have the contribution by A. So A would contribute. So A contributes the value of the coalition between A and B minus the value attached to only B. So this is what B contributes. So in that case, the value of AB is actually 9. Okay. So that's 9 minus 5, and that is equal to 4. That's what A contributes. Then what does C contribute? So C contributes the value of the grand coalition ABC minus the value of the coalition between A and B, who had already been there before C joined, and that will be 12 minus 9, and that is 3. So again, we have 5, 4, 3. Okay, 5, 4, 3. So it looks like it will all be 3, 4, 5, 5, 4, 3, and the rest of them. But we, of course, we have to keep going, right? So this is order 3. So how about order 4? So we go for order 4 again. I mean, can we just assume that it is 5, 4, 3, 5, 4, 3, and then we just do that? But I mean, let's not be lazy. Let's just keep going. Yeah, let's keep going. So we have order order 4. Order 4. Order 4 is surely B, C, A. So B starts the idea, C joins, and then A joins. So here we see that A contributes the value, so B contributes the value attached to B. That is the value of only B, the value of only B. And that is simply order 4, right? And that is simply 5, like we had before. Then next, now we see that C contributes the value of the coalition between A and C, okay, minus the value of the B that was already, sorry, this should be BC, minus the value, minus the B that was already there. So what's the coalition between BC? That is 8, right? That's 8. So we have 8 minus 5, and that is 3. Then lastly, we have that contributes, A contributes the value of the grand coalition, ABC, minus the value of the coalition between B and C, since A is the last to join, and that is 12 minus 8, and that is 4. Okay, so again, take note, 5, 3, 4. So it's all 5, 3, 4, 5, 4, 3, and the rest of it. So next we go for order 5. So for order 5 now, that is C, A, B. So C starts the idea, A joins, and then B joins. So for order 5, we see that C contributes the only value attached to C. C contributes value of only C. Okay. And the value of only C, I think, is 3. Yeah, this 3 now. So that's 3. Then we have that A contributes A contributes the value of only A. Oh, sorry. The value of the coalition between A and C, since A is joining now, minus the value of the C that was already there. Right. So the value of the coalition between A and C is 7, I believe. A and C, that's 7. So that is 7 minus, so that's 7 minus 3, and that is 4. Then what does B contribute? So B contributes the value of the grand coalition, ABC, which is 12, minus the value of the coalition between A and C that were already there. So that'll be 12 minus 7, and that is 5. So again, we have 3, 4, 5. Now, the next thing we have to do, of course, is order the sixth order. If you have many players, I mean that's going to be a lot. So the sixth player is the sixth order, right? Order 6 is C, B, A. So C starts the idea, B joins, and then A joins. So here, we see that C contributes what only C can contribute. C contributes the value of C alone, which is 3 as we know it. Then B goes ahead to contribute. So B contributes the value of the coalition between B and C, all right, minus the value of C alone, right? Which is the value between B and C, I believe, is 8. Okay, that's 8. So we have 8 minus 3, and that is 5. And lastly, what does A contribute? A contributes the difference between the value of the grand coalition ABC, all right, minus the value of the coalition between B and C, okay, which is actually 12 for ABC minus 8 for BC, and that is 4. So again, we have 3, 5, 4. So it's 3, 4, 5, 3, 5, 4, and all those. So that is so we have finished step 2, talking about the list all possible permutation. We've done that. Step 2, we've calculated the marginal contributions for each player in each order. So we go for step 3. So in step 3, step 3 is where we now calculate the Shapley values. Calculate the Shapley values here. All right. So, and from the formula, right? The formula for Shapley value already, we have it up there. This is okay, it's 1 over n factorial v. Okay, can I try to remember that? Or is it, I think it's possible to copy this, can I? Let me see. Oh, it's okay. Is this possible? Let me see. Let me see. Okay, like it's not working. I guess I have to rewrite the formula. Let me just rewrite it. So calculate the Shapley values. So, okay. Now we compute the average marginal contribution for each player. Average marginal contribution for each player. Okay, that's what we do first. And what that simply means is that uh for player A, for player A, all right, for player A, we have phi, we have phi of phi A of V. So average marginal contribution for each player in all the 6 situations, right? So player A here is 4. Player A here is 4. So everywhere it looks like player A is 4, everywhere. So first 4 here, 4 second, 4 third for A, then 4 for A. So it's 4 for A in the 6 places. So it means we simply have 4 plus 4 plus 4 plus 4 plus 4. That's 4, 5 divided by 6. And that is simply 24 divided by 6, which is simply 4. So the Shapley value for A is simply 4. Okay. So for player B now, okay, for player B, the Shapley value phi B of V will now be, so for in order 1, right? B is 5. So we have 5. In order 2, B is also 5. In order 3, B is 5. In order 4, B is 5. In order 5, B is 5. In order 6, B is 5 everywhere. Interesting. Okay. So that is 5 plus 5 plus 5 plus 5 plus 5 plus 5 divided by 6. That is 30 over 6, and that is 5. Okay, that is 5. That is 5. So yeah. So B is 5 everywhere. So just like 3, C is also 3 everywhere. I mean, I can see the pattern. C is 3 everywhere. So the value for each one remains. I don't know if it gets to change in some situations, but so far, A is always 4, B is always 5, C is always 3. Okay. Yeah. C is always 3. Okay, good then. So for B, uh, we have 5 now. Then for player, okay, I guess I want to change the marker here. So for player C, for player C, we have phi C of V, and that is 3 plus 3 plus 3 plus 3 plus 3 plus 3. So it's 3 everywhere, divided by 6. 3 times 6 is 18. 18 over 6 is 3 again. So what do we have? Can this say, thus, the Shapley values are okay. I guess I want to change the marker in this situation for effect. That's some perfectionistic trouble right there, but it's okay. So we say that thus the Shapley values are 4, right? Are 4, 5, 3 for players A, B, and C, respectively. So that's how that goes. I think it's corresponding with what we had before. I think it's corresponding with what we had before. Even for, I think it's looking about, yeah, 4, 5. Okay, it's 4, 5, 3, right? I think it was 4, 5, 3 we also got for what we did previously. So the Shapley values are 4, 5, 3 for players A, B, and C, respectively. So that brings us to the end of this idea of Shapley values. So, and it's looking like it's corresponding with the core that we also found the other time. So after this video, in the next video, I'll be talking about bargaining solutions, which involves a little bit of calculus. So you want to come along so you can also get into that properly. So if you have not subscribed to this channel, you want to do that right away so you can always get alerted. And then hit the notification bell, right? So you can always get alerted each time a new video is released. And of course, comment, let me know how helpful this has been has been for you. And of course, if you want me to teach a topic or solve a problem, feel very free to let me know through any of the channels, be it on Facebook or YouTube or wherever. All right. Then what else? Yeah, you also want to like and share so that more people can have access to this great content. So like come your way again. Keep playing the game of life with wisdom. Bye.